Alright, so we are doing problem 14.50, so chapter 14, and it gives us this little graph in the problem, and it's a function that a student plotted with a pendulum, and there's three parts to this. It asks us in part A, what is the period, the frequency, the angular frequency, and the amplitude. So the period in this problem is how long it takes the wave to reach its starting initial point. So you can see here that it starts at 6 and it takes 1.6 seconds to reach back to 6 degrees. So our period is 1.6 seconds, and the frequency, its formula is 1 over the period, so we're going to get 1 over 1.6 seconds, which is equal to 0.625, and the units for this is 1 over seconds or hertz. And then it asks us for the angular frequency. And the angular frequency is 2 pi times the frequency, which is equal to 2 pi over 1.6 radians per second. And that comes out to approximately 3.927 radians per second. And then the amplitude is the absolute value of how high and low the crest reaches on the wave. So the amplitude, you can see here, the highest and lowest point it reaches is 6 and -6. So our amplitude here is 6 degrees. Part B in this problem asks us how long the pendulum is, and we have a formula for the period where the period equals 2 pi times the square root of the length of the pendulum over gravity. So now if we plug values in here, we're going to get 1.6 is equal to 2 pi times the square root of our unknown L, that's what we're solving for, over G. And then through algebra and moving things over, we will get that L is equal to 0.636 meters. And part C in this problem asks us if it is possible to determine the mass of the pendulum. And as you can see here, all of the things that we are able to calculate based on our given data through this graph, all of these formulas are independent of the bob's mass. So because mass is not involved in any of these formulas, we are not able to calculate the mass of the bob through the given data.